make you write out what the exponents actually are, so you understand how to take them
Mrs.
out.
Carter.
Okay.
So,
I know too.
Let her teach it first.
So,
please.
you know the root of the
Quiet.
number? Mrs. Carter.
no.
Well, I got a question.
All right, so when we're going through this, the first part is vocabulary. So when I'm talking, you know what you're looking at. So there's three parts to this. There's an index, a radical, and a radicand. Okay, the index is, any idea?
Yes.
Number?
It's the first number in front of the what do you want to call it? The number that's in the word.
It's the number on the ledge. It tells you what root you're taking.
Oh,
So the index for this one is
Straight.
3. Okay, the radical sign is just the radical sign. All right, you guys always call it a square root, but is it always a square root?
No.
No. When is it a square root? When it doesn't have a number. And when it doesn't have a number, what's the index assumed to be?
1.
2. Okay, the radicand is the number underneath. So when you look at this, the radicand for this guy is what?
8.
8.
Oh wait, we're only doing the first one.
So far.
Mrs. Carter.
All right, to do this, Jacob.
Haven't we asked you questions? Haven't we done this before?
Yeah, I've already said that.
And ooh, shucks. But isn't it just pretty much like the number that's in front of it? You divide it by that, and if it's like,
Nope.
because
You look
then
for that many. Okay, here we go. First step is you take the 8 and you factor tree it. You've done this before. What are you going to use?
4 and 2.
4 and 2, and then 4 is what?
2 and 2.
2 and 2, and then circle the thingies.
Right. Now I want to show you why, because I don't think you're understanding.
Okay.
So I have 3 2's. So this is 2 times 2 times 2, correct?
Yep.
didn't we spend like an hour on this? It was like me and Austin.
All right.
Thanks.
The index, or the ratio, not the ratio, the exponent of 2 is what?
1.
It's actually 1/3, because my index is 3. So this means it's 2 to the 1/3 power. Good? This is 2 to the 1/3 power, and this is 2 to the 1/3 power. That's what it means. You are taking the cube root of 8. 8 is 2 times 2 times 2. So I'm taking the cube root of 2, 2, and 2. So they're all to the 1/3 power. Now you got to remember some things. Let's say I have x squared times x cubed. What do you do with those exponents? You add them. So this means x to the 5th. Okay, what if I have x cubed divided by x squared? What do you do with the exponents?
Subtract it.
Subtract them. So that's x to the 3 minus 2, which is 1. What if I have x cubed squared? What's that mean?
6.
Multiply. That you can't forget. You have to remember all of that. So all of that's old.
Okay.
All right. Now, this means I have 2 to the 1/3, 2 to the 1/3, 2 to the 1/3. I'm multiplying. What do I do with the exponents? You add them. How do I get to 1?
You add all of the 1/3.
So 1/3 plus 1/3 plus 1/3 is 1. So these 3 together equal what?
1.
2 to the what power?
First.
First. Because 1/3 plus 1/3 plus 1/3 is 1. That's 2 to the first. Is there any radical left?
No.
No, because they all came out because it equaled a whole number. There is no fractional exponent left. He's done. Do you understand why this works this way?
Yes.
Yes.
What's your question?
Shucks. No, I forgot it.
Okay. Now, when you're doing this, there are things you have to remember. What?
Say we got 9 and only like 2 numbers go into it, and what do we do? Because it has a 3 in front of it.
So they stay.
So you
If you cannot get 3 of them, if you cannot get a whole exponent, you cannot take it out.
And then if we say we get more like in that excess one, like say like it goes like 10 and 5, like oh no, not 10 and 5, like something like that. Say what is it like the other one where you multiply the leftover numbers?
Yep. And you leave them in. All right. Now I'm going to show you that was an odd exponent, or an odd index. If an odd index can be positive or negative. Because if I do -2 times -2 times -2, what do I get? -8, right? And if I do 2 times 2 times 2, I get +8. So I got 3 of the exact same numbers. So if I take an odd index, I just use whatever sign it has. Fair enough? What about even?
It's always gonna be positive.
Yeah, if it's not positive, you can't do it. Okay, so we've got -16.
We can do it.
And what's my index? 4, so it's even, right?
Yes, we can.
So that means I need 4 of the same number.
4.
So to get a -16, so if we take 16 and we factor tree it out, what do you got?
4, 4.
4 and 4,
2, 2.
2, 2,
2.
2 and 2. So that's 2 to the 1/4, 2 to the 1/4, whoops, 2 to the 1/4, and 2 to the 1/4. So it would take all 4 of them to equal a whole 2. Agree? But I have a negative. So that means they'd all have to be negative, so they're the same. What's a negative times a negative?
Positive.
Negative times a negative?
Positive.
Positive times a positive?
It's positive.
Can I get a negative number?
No, that's correct.
So this is not possible. Guess what kind of number this is?
An integer.
Imaginary. So if you have an even index and a negative number, you're going to put down, that is an imaginary number. Do you want to know what the true answer is?
Irrational.
No. Do you want to know?
Yeah.
All right. You know how we have 4 positive 2's, right?
Sure.
So if that was a positive 16, the answer would be,
Positive.
And then
if I said I want the 4th root of 16, what's the answer?
2.
2. If it's a negative 16, what did I just tell you that answer was? Imaginary. Just saying, that's what it is.
It's like a peso.
You can just write imaginary there and not do the rest, because we're not doing a lot of that, but you need to know that that's.
Is that like a
Yeah,
backwards?
we don't really have that.
Backwards.
Nope.
What happens if you get like a number that has a whole bunch of different roots, like 4, 3, like when you factor treat it, that has a bunch of different prime numbers?
Oh, that
How
didn't
would
come
you do
out.
that?
We're there. You gotta wait. Give me
Okay.
2 seconds and we're going to do it.
Oh.
Okay, next question was, what if they don't all come out? And that's what we're doing here in a little bit. All right, up here, we have -125, and it's a cube root. Can I do it?
No.
Yes, because it's an odd index. So what you do is we take this negative, and you remember those annoying little brothers?
no, I don't know.
Yeah. So we have to deal with him, but we're not going to worry about him. We're just going to make our answer
I don't have
negative.
any siblings.
You are so lucky. All right, so the first thing we do is we take 125 and we factor tree it. What goes into 125?
5. 5 and
25.
50.
Okay, this means 5 to what power?
3rd.
1/3 power. So these are all, why are they to the 1/3 power?
Because the thingy is the index.
Because
is
my
3.
index is 3. So the index was 4, these would all be to the 4th power. How many A's do I have?
You have 6.
That's true. I have 6 A's. How power are they to?
The 1/5.
No,
1/3.
they're still to the 3rd power, because my index is 3. The index is always what your fraction is.
Oh, so we got 2 out of that.
So I have to get to 1. So 1/3 plus, how many 1/3 do I need
Oh,
to
you
get to
three.
1? 3. So I need 3 1/3,
3 1/3.
3 of them, and
3.
3 of them. What does this equal?
1.
What's 5? No, that equals 5. Because it's 5 to the 1/3, it's 5 to the 1st. Yes, I would agree. What's this equal?
And it's the first part, or
Second.
And this is also a to the first. Okay, what's a times a?
A squared,
So my answer is,
5a squared,
but who can we not forget about?
the square,
This annoying little breath.
negative 5.
Negative 5a squared.
Just think of a little bit.
Are we getting it?
Yeah.
Okay, your turn.
Oh,
If there's no index, it's assumed to be
Go.
2.
Wouldn't there be
So
a
my
half
index
of-
is truly 2. Okay, what does 16 factor into?
4.
Okay,
Two.
so that means I have 2 to what power?
1/4.
Uh-uh,
1, 2,
1/2. It's your index. And I have 4 2's to the half power. Now, if you know the square root of 16, do I have to do all this work?
No.
What's the square root of 16?
4.
4. Do I have to do this?
No.
No. If you know that, you can write down
4x to the 10.
Nope. Okay, how many x's are there?
10, so it could be 4.
Also, it would be 5, it would
4x to the
be 4x to the 5th.
I could
Yep.
But so, hey,
slow.
question.
Hang on, I'm not done writing 1/2.
No.
Okay, what?
Okay, so if there's a perfect square in there and you just do it,
Yes,
and then like you can divide the
yes.
thing by 2.
That's the shortcut. I'm going to show you that in a second. All right.
I don't get the step after that.
Okay, now you circle. Okay, you have to get to 1 for an
Like
exponent.
every time you have to get to 1.
Yep. So how do I get to 1? 1/2 plus 1/2.
Oh, 4. So I'm gonna do
Okay, what's 1/2 plus 1/2?
4.
1/2 plus 1/2? 1.
You
1/2.
gotta know the answer.
Oh, yeah, okay, I got it.
1/2 plus 1/2, like basis.
Yes.
So this is 2 over 2, which is 1.
Because the square is
All right? So it takes 2 of these to get to 1. Because I got to get to a 1 as an exponent.
only to the it's only to the second power. So
Jacob, go to the back. Now, get a chair, go backwards. Okay, so there's 1. There's 1. Then we got to circle all my groups
So
of
4 squared. and
So this
X
is, what does this equal right here?
1,
This is 2.
2, X.
How many x's?
5
So what's my answer?
4x
2 times 2 is 4. How many x's? To the 5th. And it's,
negative
Negative.
4.
all right, that's the long way. If you need to do it that way, that's fine. Okay,
Short way.
I am.
Do it that way.
I'm gonna erase this. Is there-
No.
Then write down.
You idiot.
Don't erase it, just keep it.
It's, no, I got you, because he
No,
has
you don't.
Erase
Just
the
erase it.
Okay,
Wait, that's
this is
it.
gone.
That was the part I didn't have yet. It's
Well, why were you
okay.
writing it down with it?
All right,
Just kidding.
if you know
Oh.
there's a shortcut. So this is a 2, right?
Yeah.
Okay, and you know the square root of 16,
Yeah.
which is 4. So I can put negative 4. You can take
Right.
x. Now that's 10, and what do I do with the 2? How do you rewrite that?
Divide
10 divided by 2. So what is that?
negative 4x to the 5th.
Wait,
Done.
how?
What? Why did you show us that before?
Yeah.
We negative.
Multiple times.
So does it work with any other one or only?
Wait,
Always first.
what about the negative?
Negative just came from here.
So
If he's outside, you have to write him down.
So say that's 3.
If it's outside, it's okay. If it's inside, it is not okay.
Not okay.
Not,
It's 3. And
No.
it's
not okay.
Instead of
Quiet.
it's 9, and then divided by 3. So we got 2.
Okay, so now you have 2 ways. I don't care which method you use.
Sure.
You pick the one you like, and you do it all the time.
You can't do the.
All right. Okay, now, things that don't work out pretty. So those are pretty ones. What's the question?
You can't do it like if you don't know, what if it doesn't have a square root?
They will always
Then you
be
gotta do
square
it.
root.
That's what we're doing now.
Oh.
You gonna listen?
Yeah.
All right, here we go. What's my index?
2.
2, because this is assumed to be a 2. Does 24 have a perfect square?
No.
No.
So can I do the shortcut on this one?
No.
No. So So I have to take 24 and factor tree it. What do you want to use?
Let's do 6 and 4. That sounds like a good one.
2 and,
Oh, okay.
listening, 2. 6 is 3 and 2. So I have 3 to what power?
The first,
What's my index?
1/2.
1/2. Then I have 2 to the,
1/2.
and I have 3 of those.
Yeah.
Okay, how many x's do I have? 6 of them,
6 to the 1/2 power.
all to the 1/2 power.
Yep.
My God.
So you take all.
And I have 5 y's,
To the 1/2.
all to the 1/2 power.
Wait a minute. So would you get like
Wait. Okay, so how many does it take to get an exponent of 1?
2.
2 of them. So what can I circle?
The 2 2s.
I can circle 2 2s.
You can circle all of the x's.
I can circle 3 sets of x's
And 2 sets of Y's.
and 2 sets of
Or
y's.
else you throw them in the garbage.
So, no. So what does this equal here?
2.
2,
2. 1. Or,
x, 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 y, y. All right, so what do I have so far? Those all go outside.
You have 2
2x to the third and
Y.
Y squared. Now I have my radical
also
square
that's
root.
what
Okay, what did I not circle?
3 and 2 and
a Y.
So what do I have to do with this 3 and this 2?
Times
What's 3 times 2?
6.
What else did I not circle?
Y.
Y.
It would make more sense to circle on inside.
No, because that equals a whole. Because 1/2 plus 1/2 is 1. That's 2 to the first. This is still to the 1/2 power. And remember, this means 6 to the 1/2 power. Y to the 1/2 power. Is what's left over, because there's still fractional exponents.
Oh, right.
Okay, you want to see a shortcut?
Yes, please.
Okay, everybody ready?
Yeah.
I didn't write that down.
Okay, it's going away. All right, here we go. This thing is erasing very slow today.
Well, maybe it's the operator's fault.
Oh, never. All right, shortcut. All right, what do you know about 24? You told me
It's
that was 4 and 6.
actually
Agreed?
6 and 4. But
Yeah.
Now, what's the square root of 4?
2.
Does 6 have 1?
No.
But you have to be careful, because if you don't take out a square root, you're still kind of in trouble.
No.
So you're still better off to do 2, 2, 2, and 3.
No.
Okay, and we need how many of them? This is all to the 1/2.
Oh, we need 2 2's.
So the 2 is going to come out, and the 6 is going to stay in.
Yeah.
Okay, now let's look at these. So this means this is x to the 6 divided by what?
2.
2,
So
and y to the
5th.
5 divided by
2.
2. What's 6 divided by 2?
3.
So that's 3 whole ones.
So that goes x.
So that goes outside, because there was nothing remainder. Now let's look at 5 divided by 2. What's 5 divided by 2?
2 and 2 and 1 4.
2.5.
2 and 1
All
4.
right, now I want you to go backwards in time. Do you remember when you were little and you had to tell me the remainder?
No.
No.
Yes.
Yes. So 5 divided by 2, what's the whole number and what's the remainder?
2 and 1/5.
2 and 1/2.
1/2. Oh.
Are you there? All right, so if I take 5 divided by 2, right, you would tell me that's 2 with a remainder of 1. Agreed?
Sure.
So that means I have 2 whole ones. That's y squared. What's my remainder?
1.
Y to the first.
I don't like that way. For that
That's the shortcut. You may do either way. I am
don't
not
have one.
going to say you have to do it one way or the
one.
other.
To be honest,
You pick one. What 3 and the 2?
I know how you got it.
The shortcut way or the other way?
Short way.
You take
Right
6
on the
divided by
circle.
2 and you have 3.
Oh,
5 divided by 2 is 2 with a remainder of 1. Brady,
You're doing one.
say it one more time.
You're doing like 1/4.
Yeah,
Would you do? And you only have 2 Y's.
I should wear that.
it'd stay inside.
So if you maybe Y.
I'm not.
Okay, if you're taking the 4th root of y squared, and that's all there is. Okay, that's it. So that's y to the 2/4. There's no whole ones, but that does reduce. Is that what you're talking about?
I mean, like, if you have, because when you're writing them all out, like all the letters, would you, and then you have, if you just have 2 Y's, so you can't make a whole number, what would you do?
They just stay inside.
So, no, what would the, like, exponent be?
2. If I cannot, let's say this is 3, so it doesn't reduce. So 3 is not divisible by 4, right? So there are no whole ones. I don't have enough to make a whole one, so it just stays this. This is done. Because nothing comes out. If you do not have a whole one to take out, you leave it alone. Okay? Okay, next question. All right, get going on your prep. Okay, are we good?
Wait, is the answer again? 3xy squared.
Square root 10 as Yep. Okay, here we
I
go.
got the next one.
Now we are dividing. Okay, so we're going to divide these. We're going to multiply these, and we're going to clear these. So there's a lot we're going to do. That was all review. You're supposed to know all of that. So now,
Subtract the. My bad.
okay, if the
I did it.
indexes are the same, okay, so if they're both square roots or cube roots or 4th roots, and they're divided, we have 2 ways of writing them. We can write the numerator over the numerator, or we can put them all underneath one big radical. And it depends on what they do, what we have to do. Okay, sometimes we have to do both. Now, if they reduce, we prefer this way. This is nice.
It is?
This one here's not as nice.
No?
We don't like him.
Okay.
All right. So we're going to take the 2 that are written. They're both, what are these indexes assumed to be?
2.
2. So they're both square roots.
Yep.
So I can put them together. When I put them together, I'm hoping they reduce.
Yeah.
So we take 162 divided by 3. Does that work?
Yes.
Yeah, it's 54. Life is happy. Okay, when we divide, what do we do with exponents?
Subtract them.
Subtract. So what's 5 minus 2?
3.
3.
Right.
Everybody get this?
Yeah.
Now you do what you did before. What's 54 reduced to? What numbers do you know? 9 and 6?
3, 3,
2 and
3, and 2,
All to what powers?
1/2,
Okay, how many do I need?
2 3s.
So that goes
Outside.
here.
There.
And then 3 times 2 is,
6.
and that goes
There.
here. Now, I have 3 Y's.
And then it would be 1 Y inside.
So these guys make a whole one, so he goes outside. Nobody likes him, so he goes inside.
That's kind of hard.
I know.
Is this correct?
Yeah.
Oh, I was gonna.
Okay, do we have questions?
No.
Okay, do your practice
Wait, this
quickly.
part I'm done with practice.
Hang on. Now the next part, guys, is not
Easy.
pretty. It's not hard, but it is not pretty. Okay, now you look at this. We have 5x squared over 12y squared z. What's my index? 2. So my index is 2 because there's nothing there. Now, does it reduce?
Yes.
No, 5 and 12 don't reduce. X, Y, and Z do not reduce. So this is not pretty.
No solution, imagine.
Oh, no.
No, there is a solution.
Now,
Imagine.
when you're doing this, you are not allowed to have radicals on the bottom. It's just one of those lovely math rules that somebody made up and you can't have them. So you have to make them go away. So in order to do this, I need groups of what?
2.
2, because this is a 2 down here, correct? So we break it up into two radicals, the numerator and the denominator. The denominator is what I have to work with. Is everybody good so far? Okay, so now we take 12 and we factor tree it. What is it? 2 and 3. So I have 2, 2, 3, y squared, z. Everybody good? Everybody understand this step? Okay, I need groups of what? 2. So everybody has to have a partner in this case because my index is 2. If it was 3, I'd have to have 3 of everybody. Okay? But it's a 2 this time. Do I have 2 2s? Yes. So we like those. He goes here. Good?
He goes where? Then you.
He just goes outside. I put him under there. All right. Do I have 2 3s?
No.
So how many do I have?
1.
How many more do I need? 1. So I make another radical, and I'm going to put a 3 in here
Why?
so that I have 2 of them. So now this guy and this guy are going to go together. Are we good? So,
Make it up.
yep. So do I have 2 3s now?
Yeah.
So that comes out as my 3. Do I have 2 y's? Yeah, so we're happy with him. I just write him down. Do I have 2 z's? So I need another z. So I put him over here. So now I have 2 z's, and he'll come out as a z. Do you see how everybody has a pair now?
Yeah.
All right, but whatever you do to the denominator,
You have to do to the numerator.
you have to do it in the numerator. So I have to put him on the top 2. So whatever I came up with down here must go in the numerator. Okay, questions so far?
How'd you get 15?
Hang on. So now you have to take these 2 and multiply them. What's 5 times 3?
13.
I still have an x squared and I still have a z. Everybody good? Okay, do any of those reduce? Will 15 reduce?
No.
No, because he's 5 times 3. How about x squared?
No.
Yeah, because how many x squareds do I have?
2.
2. They're both to the half power, so they circle and come out as 1. Does a z come out? Nope, so he stays. This is your answer.
Oh, I like that.
That's your answer?
That's your answer.
The next one's really confusing.
Okay, I need a question. That's new.
Yeah.
Jacob?
Okay, so, when we're working on it and you get, I know that you simplified the 12, and you get the leftovers 3s, so like, just kind of like the last one, we get 2 the groups now.
Mhm.
And so the leftovers 3, then,
What are you talking about?
yeah, I'm saying wait, I'm getting to the point, so, and it's a z, so you have to multiply to z, so they each have like the same thing on top.
Yeah, so they all have 2s. You're looking, this one here was groups of 2 because my index was 2. Could I have done 3 and made you do groups of 3?
Okay, what happens if they
absolutely.
do, what happens if, like, oh, so if it doesn't have a group, it has to get multiplied with the thing?
Were you not listening?
I know.
Oh, I was kind of working on the paper.
Okay, everybody, you're up.
I know.
Let's do a little bit of this together.
I got
Okay, you're looking, what's my index? What's my index? 2. So I have a 3, I have 1 y, and I have 3 z's. I need groups of 2, right? So I got to figure out what I have to multiply by. Okay, and I don't want anything down here. So what do I need? Do I need another 3?
Yes.
Yes. So once I put another 3 in, I now have 2 3s. So that goes here.
You got 2 things. You technically got 1.
Correct. I have 3 to the 1/2, which gives me a whole 3. Okay, I have y to the 1/2. Do I need another one?
Yeah.
So I need another one, so this and this gives me what? Y. Okay, these are to the 1/2 power. So I already have 1 z, but I have this dude.
Yeah, so you can multiply them.
So I need another one. So I need a z in here. Okay, so how many z's come out?
Z squared.
Z squared. Okay, we've done our denominator. Do we understand this?
Yes.
Okay, but whatever I do to the denominator, we have to do to the top. So I have to multiply this guy by,
Are you doing what about the other Z? Are you gonna finish your note? See that circle? That go over there.
That's why it's z squared. Because this is 1z, and this guy is 1z. So z times z is z squared. Right, does it make sense, Ash?
Alright, so this is the one